Hi everyone, Assalamualaikum. In this video, we will continue with some useful and related integration formulas involving integration by partial fractions. From the previous video, we already discussed the formula of integration of ax plus b to the power of n dx when n not equals to -1 and n equals to -1. Okay. Alright. So in this video, we will continue with this formula. Okay. This formula comes from formula number 15 in appendix. Okay. Which is integration of 1 over a squared plus x squared dx equals to 1 over a inverse tangent x over a plus c. This is a useful formula for denominator with irreducible quadratic factors in partial fractions. So in this video, we will discuss some examples using this formula. Right? We look at example 3a. Let's say we want to integrate 2 over 4 plus x squared dx. Okay? We have denominator with quadratic function. Okay? And we have numerator with constant. Okay? Let's say we have 2 here. Okay? Alright, when we compare from appendix, from table of integral, it is similar to formula number 15. Okay? Because we have 1 here, 1 mean constant, and then we have denominator in quadratic function. Okay? A here means constant. Alright? And after we integrate constant over quadratic, the answer equals to 1 over a inverse tangent x over a plus c. Okay? Alright, so from this formula, when we integrate 2 over 4 plus x squared dx, where numerator is a constant and denominator is a quadratic, the answer should be in terms of inverse tangent. First, we can move out constant 2 from integration sign. And then we can write 2 integration of 1 over. Alright, from this formula, since the answer equals to inverse tangent, and from formula number 15 here, we need to write a squared plus x squared. A means constant. So from 4 here, we need to write 2 squared plus x squared dx. Okay. Then we compare from this formula, our a equals to 2. Right? So after we integrate using this formula, we still have 2 in front. And then after we integrate, no more integration sign. Okay? And when we integrate 1 over 2 squared plus x squared dx from this formula, the answer equals to 1 over a. Now our a equals to 2. And then inverse tangent x over a. And our a equals to 2. And then plus c. Okay? After that, we can simplify 2 here and 2 from denominator here. So the final answer equals to inverse tangent x over 2 plus c. Right? Alright. How about example 3b? Let's say we have integration of 1 over 2 plus x squared dx. We have denominator with quadratic function and numerator with constant. Right? And then we refer from appendix, from table of integral, it is similar to formula number 15. Okay, when we integrate 1 over a squared plus x squared dx, okay, numerator equals to constant, denominator equals to quadratic, the answer equals to 1 over a inverse tangent x over a plus c. Right? So from this formula, when we integrate 1 over 2 plus x squared dx, first we need to write constant 2 in terms of a squared. So we can write 1 over sec 2 squared because when we simplify cert2 squared, we will get back 2 from the original question here. Okay, and then plus x squared dx. So now when we compare, our A equals to cert2. So after we integrate using this formula, the answer equals to 1 over A, where our A equals to cert2, and then inverse tangent x over A, our A equals to cert2 plus C, right? And this is the final answer when we integrate 1 over 2 plus x squared dx, right? Right now, we look at example 3c. Let's say we want to integrate x over 4 plus x squared dx. Okay. From here, we have denominator in quadratic function and numerator in linear function. Okay. Since we have x to the power of 1 here. Okay. And when we compare from appendix, from table of integral, it is similar to formula number 15. Okay. Where the answer equals to 1 over A inverse tangent x over A plus C. But in this formula, the numerator should be constant. And then when we compare from the original question, our numerator not a constant, but this is linear function. Okay? We cannot move out variable x from integration sign. Okay, we only can move out constant from integration sign and never move out variable from integration sign. Okay. Alright, since we cannot use this formula because this formula valid for numerator is a constant only, so we no need to write denominator into the form of 2 squared plus x squared, right? Because the answer is not equals to inverse tangent. We only write into the form of a squared plus x squared when the answer equals to inverse tangent. So now, from the given question here, the answer not equals to inverse tangent since our numerator not a constant but linear function. Right? So from here, since the denominator containing x squared and numerator containing x, okay, so from here our denominator containing x squared and our numerator containing x, okay, which are related in terms of derivative, okay, because when we differentiate x squared, we will get term containing x, okay, so we need to use u substitution. So in this case, we not refer from this formula, but we use u substitution, right? So when we write 4 plus x squared into the form of 2 squared plus x squared, is not a correct method. It's a wrong method, okay? Because the answer is not equals to 1 over A inverse tangent x over A plus C, right? Alright, so from when we compare to example 3a, okay? From example 3a, when we compare, the question looks similar, but from example 3a, we have integration of 2 over 4 plus x squared. Okay, our numerator equals to constant 2. In this case, we can refer from table of integral in appendix, okay, formula number 15, because our numerator is a constant, okay, so we need to write denominator into the form of a squared plus x squared, since the answer equals to inverse tangent, right? But in example 3c, our numerator is a linear, not a constant. So we no need to write denominator into the form of a squared plus x squared because the answer not equals to inverse tangent. Okay, but we need to use integration using u substitution because term containing x squared and term containing x here are related in terms of derivative, right? Because when we differentiate x squared, we will have term containing x, right? We see again example 3C. In the previous slide, we show you the wrong method but common mistake to integrate x over 4 plus x squared dx. The correct method is as follows, right? From denominator here, we have quadratic function. And from numerator, we have linear function, right? Since the denominator, which is containing x squared, and the numerator, which is containing x, are related in terms of derivative, so we need to use integration using u substitution, right? And when we use integration using u substitution, we need to identify u. Okay, so from here, we choose u equals to 4 plus x squared, right? And every time when we use u substitution, we will have derivative part and integration part. Okay, under derivative part, after we define u equals to 4 plus x squared, we need to differentiate to find du over dx. And when we differentiate 4 plus x squared, we get 2x. Okay? And after that, we need to write dx as a subject. And to write dx as a subject, we need to cross multiply. So we get dx equals to du over 2x. Right? And after that, we substitute back into the given question. Okay? We just replace u and dx. Okay? So our u equals to 4 plus x squared. And we still have x in numerator. And then we replace dx equals to du over 2x. Right? If we choose the correct u, we can simplify all term containing x. Okay, so from here, we can simplify x from numerator and x from denominator. And at the same time, we can move out denominator constant 2 outside integration sign. Alright, so after we move out, so we get half and then integration of 1 over u du. So no more variable x. Now we have u and du. Okay, we have term containing u and du. No more variable x. So from here, we can integrate with respect to u. Okay, so after we integrate, we still have constant half. Okay, and then when we integrate, no more integration sign. And when we integrate 1 over u du, the answer equals to ln u plus c. Right? And after that, and before that, every time when we have numerator, the degree of numerator less 1 from the degree of denominator, the answer equals to ln. Okay, when we integrate, right? And final step, we replace back u in terms of x. So we have half ln u equals to 4 plus x squared and then plus c. We put 4 plus x squared in modular sign, okay? Because ln cannot be negative, okay? So that's why we put modular symbol, alright? So this is the final answer when we integrate x over 4 plus x squared dx, right? This is the correct method, right? Or We also can integrate this question using quick method. Okay? Using quick method, we can use this formula. Integration of u prime over u dx will equals to ln u plus c. Okay? Means if we have numerator is a derivative of denominator, when we integrate, the answer equals to ln denominator. Okay? And then plus c. Okay? So from here, why we get this formula? Okay? From integration of u prime over u dx, okay, we can put u prime beside 1 over u. Okay, so we can write integration of 1 over u times u prime times dx. And u prime is actually du over dx. Okay, and then from here, we can simplify dx here and dx from denominator here. And after we simplify, so we get integration of 1 over u du. And when we integrate 1 over u du, the answer equals to ln u plus c. Okay, that's why when we integrate u prime over u dx, the answer equals to ln u plus c. Alright? Or in other words, when we have numerator with derivative of denominator, when we integrate, the answer equals to ln denominator plus c. Right? So from the given question here, we have integration of x over 4 plus x squared dx using quick method. Okay? The original question is integration of x over 4 plus x squared dx. If we differentiate denominator, which is 4 plus x squared, the answer equals to 2x. From here, we have numerator equals to x only. Okay, so we can adjust the constant. Okay, we can adjust using constant only, never adjust using variable. So now we want 2x because we want u prime, or in other words, derivative of denominator. So we can put 2 here. Okay, since derivative of 4 plus x squared equals to 2x, so we must put 2 here. But from the original question, we doesn't have 2 here. Okay, so to eliminate back 2, so we need to multiply by half, so that when we simplify 2 and 2 from half here, we get back the original question. Okay, and then from here, after we integrate, we still have constant half, and then when we integrate u prime over u, okay, using this formula, the answer equals to ln u. Okay, so from here, 2x is actually u prime. Okay, means the derivative of u. Because when we differentiate 4 plus x squared, the answer equals to 2x. Means that if our u equals to 4 plus x squared, the answer equals to 2x, which is u prime. And when we have integration of u prime over u dx, the answer equals to ln u. Okay, and our u equals to 4 plus x squared plus c. Okay, this is quick method. Right? So using quick method, we only have 2 rows, okay, to complete the solution. Right? And when we compare from this solution, okay, this solution we use substitution, and this solution we use quick method. Okay, and when we compare, the answers are equal, right? Because these are the correct method, right? Got it? Now we look at example 3D. integrate 2 plus x over 4 plus x squared dx. Okay, so from here, we have denominator in quadratic function and numerator in linear function, right? Since the denominator containing x squared and the numerator containing x are related in terms of derivative, so we need to use U substitution. Okay, and when we use U substitution, let's say we choose U equals to 4 plus x squared. Okay, and then after we define U, we need to find du over dx. Okay, and when we differentiate 4 plus x squared, it equals to 2x. Alright, and then we write dx as a subject, which is equals to du over dx. Okay, and after that, we substitute back into the given question. We just replace u and dx. So we still have numerator 2 plus x, and then over, we replace 4 plus x squared equals to u. And we replace dx equals to du over 2x. Alright? And after that, let's say we simplify x from numerator and x from denominator here. Alright? But wait. Actually, we can't simplify x. It is because 2 plus here means addition operation. Okay? And then 2 from denominator here is multiplication operation. So we can't simplify variable x. Right? Actually, this is wrong method. So never do this. Right? In this case, we need to separate the fraction. Okay? Now, let me look back example 3D. In the previous slide, we show you the wrong method to integrate 2 plus x over 4 plus x squared dx. The correct method is as follows. Okay? In this case, we need to separate the fractions. And after we separate the fraction, so we get integration of 2 over 4 plus x squared plus x over 4 plus x squared dx. Alright? And then we can separate one by one. So, we have integration of 2 over 4 plus x squared dx, and then plus integration of x over 4 plus x squared dx. Okay, first we separate the fraction, and after that we integrate one by one. Right? And then integration of 2 over 4x squared dx, we already discussed in example 3a. Okay? When we integrate 2 over 4 plus x squared dx in example 3a in the previous slide, the answer equals to inverse tangent x over 2 plus c. Right? The answer is in terms of inverse tangent since the numerator is a constant and the denominator is a quadratic function or irreducible quadratic function. Right? And then we can write the answer here. Okay, after we integrate 2 over 4 plus x squared dx, the answer equals to inverse tangent x over 2. Okay? No need to put plus c. We just put plus c at the back after we finish all the integrations. Okay? And then when we integrate x over 4 plus x squared dx, okay, we already discussed in example 3c in the previous slide. Okay? In example 3c, when we integrate x over 4 plus x squared dx, the answer equals to half ln 4 plus x squared modulus plus c. Okay, so we can put the answer here. Okay, means that when we integrate 2 over 4 plus x squared dx, numerator is a constant, denominator is a reducible quadratic factor, so we get the final answer equals to inverse tangent. Okay, and when we integrate x over 4 plus x squared dx, numerator is a linear function and denominator is a quadratic function. So the answer equals to half ln 4 plus x squared modulus plus c. Okay, this is the final answer when we integrate this function. Okay, we separate the fraction first, and after that, we integrate one by one. From the first integration here, our numerator is a constant. So the final answer should be inverse tangent. And then the second integration here, our numerator equals to linear. Okay, so the final answer is in terms of ln. Right? Got it? So this is the final answer. Okay. Up to this point, you can try exercise 3. Okay. Evaluate the following. Question number 1, 2, 3, and 4. Okay. This is the final answer for number 1, and this is the final answer for number 3. Okay. You can check the final answer using Symbolab for question 2 and question 4. Right? And this is the formula related to this question, right? And last but not least, try this. Question number 1, 2, and 3, right? From question 1, 2, and 3, it looks similar, but actually, they are different, right? So you can check the final answer using symbollab.com, right? Good luck! Coming up next, integration by partial fractions. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.